We've looked at solving first order linear differential equations. What I've got here for you is a few questions based on this. I'm going to present you with the questions. What I want you to do is pause the video, have a go at the questions, and then come back and check your answers with the working I'm going to present to you. So, here you go. 3 questions for you. I want you to solve each of these differential equations and get me the solution to them. So, remember the 5 steps we talked about in the previous video. Have a ping at these now. First question was dy by dx plus 2 over x times y equals x, and I want to solve that. Now remember the 5 steps. The first step was to make sure it was in the correct format. So dy by dx plus p of xy equals q of x. Coefficient of dy by dx always had to be 1. Well, good thing is this one is in the correct format to start with. Great. We then had to calculate the integrating factor. So I of x equals e to the integral of p of x dx. Now the p of x comes from the function that is the coefficient of the y, so it's 2 over x. So calculate the integral of p of x to begin with. So I'm after the integral of 2 over x dx, which is equal to 2 times ln x. Now again, we can just ignore the constant of integration that comes afterwards. It's just generic. We can then work this through, and what I'll end up getting is ln x squared here. So my integrating factor I of x becomes e to the ln of x squared, which simplifies down to just x squared. So what that now means is I can then rewrite my equation as d by dx of my integrating factor times y, so x squared times y, and I know that that's going to equal the right hand side, x times my integrating factor, which is then going to be x cubed. Because of this format here, if I were to then use the product rule to differentiate it, I would end up getting something that's the equivalent of this side times this integrating factor x squared, which is great. Now I integrate both sides with respect to x, and what I'll get is x squared times y is equal to the integral of x cubed, which is then giving me x to the power of 4 over 4 plus c, my constant of integration. What we can then do is stick the x squared across, and what I'll end up with is that y equals 1/4 x squared plus c over x squared. And that there is my solution to this one. Second question was x squared dy by dx minus x cubed plus xy equals 0. Now this one, looking at it, looks like it'll be a little bit more complex, but actually it just requires shifting a few things about. So I need to get it in the format of dy by dx plus p of x times y equals q of x. So what I need to do is identify the parts I need to shift around here and then move them according to the rules that I would normally use. Now p of xy, that would be this term here, so that's going to stay on the left hand side. This x cubed part has no dependence on y within it whatsoever, so it's not got no y term. So that is going to get shifted across to this side here, and I'm then going to divide everything through by x squared to get rid of that as the coefficient of dy by dx. So I'll end up getting is dy by dx plus 1 over x times y equals, well this is going to become x cubed, but I'm then dividing the x cubed by x squared, which is equal to x. Now this here, fairly straightforward to solve as long as we follow the same steps as we have done all the time. Step 1, calculate my integrating factor I of x. Again, we know it's equal to e to the integral of p of x dx. And as we saw here, the p of x is the coefficient of y, so the integral of p of x is equivalent to the integral of 1 over x dx, which is equal to ln x. So my integrating factor I of x is equal to e to the ln x, which is just equal to x. What I then do is multiply through, and I can write it in the standard solution. So I know then that d by dx of x times y equals x times the integrating factor, so that equals x squared. We then integrate both sides with respect to x, and I'll then end up getting x times y equals 1/3 x cubed plus my c, my constant of integration, shift the x across, and I get my final solution that y is equal to 1/3 x squared plus c over x. There you go, my solution to that one. And again, if I had a set solution for y and x relating each other, I could substitute them in here and get a single particular solution for the entire thing. Third one was involving a bit of trigonometry. So cos x times dy by dx minus 2y times sin x equals 1. Just because there's trig in it though, doesn't mean any of my steps change. It's still the exact same set of steps that we work through here. Rearrange it to get it in the right format. Doing that, I divide everything through by the cos x, and I get dy by dx to equal 2y sin x over cos x equals 1 over cos x. So what I can do is find the appropriate parts that I want. So I then know that my integrating factor, I of x, equal to e to the integral of p of x. Now p of x in this case is given by this part here. Sin x over cos x times the negative 2y. So negative 2 times sin x over cos x. I know sin over cos is tan, so it's going to be equal to e to the integral of negative 2 over tan. So what I'm going to do is put the negative 2 outside as a common factor. So negative 2 tan x dx. Now we know the integral of tan is ln cos. So what that's going to equal is e to the power of negative 2 ln of cos x, which is then, if I take the negative 2 up as a power, going to equal to e to the ln of cos x to the negative 2. The e's and the ln cancel, so I'm going to get 1 over cos squared x. What I can then do is take this, put it back into the format that I want, and I'll end up getting my solution. So what I'll know is that d by dx of my integrating factor to 1 over cos squared x times the y, that equals this side here, the 1 over cos x, times my integrating factor, 1 over cos squared x, that equals 1 over cos cubed x. What I can now do is integrate both sides with respect to x. I'll end up with 1 over cos squared x times y equals the integral of cos cubed x with respect to x. And calculating that, what we end up getting is sin x minus sin cubed x over 3 plus c. Just use our set of steps that we know from before about calculating an integral like this. Think back to the trigonometry stuff we did in the previous block. What I can then do is multiply through by the cos squared x. What I'll end up getting is that y equals sin x cos squared x minus sin cubed x cos squared x over 3 plus my constant c times cos squared x. So a slightly more complex solution in this case, but still follows the same set of steps nonetheless. The only extra bit of difficulty came from integrating 1 over cos cubed x with respect to x. These are the sets of steps that we have to follow every single time we want to solve a linear differential equation in that format. And if we can remember this, we're laughing the whole way through. None of them should cause us an issue. Every single one of them should be relatively straightforward for us to solve, and they should be things that we're able to handle and cope with at this level we're working at.